Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied about the IUPAC nomenclature of the structure that was given of alkane, and same as we have also did the structural formula of the IUPAC nomenclature that was being provided to us. So this is basically the topic of alkane that we are studying. So the IUPAC name and the structural formula, that is over now, but now we are dealing with how this kind of alkanes can be prepared from various different chemicals. So let us talk about that. So friends, now we are going to talk about the different methods of preparation of alkanes in which different chemicals would be used so as to make a particular alkane. So there are various methods to prepare alkane, and So now we are going to discuss about what are the different chemical or different methods from which we could prepare alkanes. So let us talk about it. So talking about the first one, that is, we could prepare the alkane from unsaturated hydrocarbons. So this is the one that we could prepare from unsaturated hydrocarbons. Secondly, we could prepare it from decarboxylation of basically sodium salt of carboxylic acid. So therefore, we could prepare the alkanes from sodium salt of carboxylic acid. And lastly, we could prepare it from alkyl halides. So these are the three methods from which we could prepare the alkanes, and the first one is basically unsaturated hydrocarbons from unsaturated hydrocarbons. In this process, we are going to deal with the hydrogenations of the alkenes and alkynes. So from that we could prepare alkanes. The second is to from sodium salt of carboxylic acid, that is, we have to decarboxylate the process and so as to make this one. And the last is alkyl halides. So these are the three different chemicals from which we could prepare alkanes, but there are various methods also that are being involved in it. So let us discuss about it with detail. Starting with the first, that is from unsaturated hydrocarbons. We know what is actually unsaturated hydrocarbons, because in this we have a chapter we have learned about what is saturated hydrocarbons and yes, what are unsaturated hydrocarbons. And unsaturated hydrocarbons are those carbons which are those hydrocarbons which consist of at least one carbon-carbon double bond or one carbon-carbon triple bond. So because the unsaturated hydrocarbons are being divided into two parts, that is, one is alkene and other is alkyne. So now we are going to prepare, or we are able to prepare the hydrocarbons when it comes to an alkane, that is a saturated hydrocarbon, from alkene as well as from alkyne. So what is this process called, and what are the methods that are being involved, or what are the catalysts that are being involved in this process? Let us talk about that too. So now, talking about the first one, that is, we will prepare a saturated hydrocarbon, that is, we will prepare alkane from a unsaturated hydrocarbon, basically known as alkene. So let us do that also. Suppose if we have alkene, and since we know that alkene has a molecular formula, or we could also generalize that in the form of so this is the general representation of alkene, where we could say that this both the R can be same also, as well as can be different also. And suppose if both the R or both the alkyl group, this R is nothing but the alkyl group that I will write over here. So these are the alkyl groups, and they might be same or they might be different, and moreover they can also be hydrogen. Suppose if this is hydrogen and this is also hydrogen, so therefore this whole molecule that has been present in front of you, that would be basically become CH2 double bond CH2, and CH2 double bond CH2 is nothing but ethene. So now ethene is basically an unsaturated hydrocarbon, and specifically it is an alkene. So now what we have to do is we have to convert this alkene or this unsaturated hydrocarbon to alkane. So for that, what we'll be using? We'll be using basically hydrogen. The reason behind that is because the need of the reaction is that we want the product to form a saturated hydrocarbon, basically known as alkane. So in this case, as you could see that the hydrogen is now been forming, but so in this case, as you could see that the carbon and carbon consist of double bond, and moreover we could add any chemical, but any chemical won't give you saturated hydrocarbon unless we add hydrogen. So suppose in this case, suppose if we have added hydrogen in the form of H2. H2 means a hydrogen gas, that is what we are talking about. Suppose if we have inserted hydrogen in this, and this hydrogen when is inserted in alkene, and this reaction don't take place by its own, we have to insert an catalyst, and that catalyst is basically rare nickel. So rare nickel is nothing but a highly small pieces of the nickel, or we could say a highly porous nickel, where this alkene, which is also in a gaseous form, this gaseous form of alkene and the hydrogen gas that we have, all they both are of the gaseous state. So by doing this process, or by supplying of a catalyst like rare nickel, so this will increase the reaction so as to convert an alkene and a reaction of alkene and hydrogen to an alkane, and that alkane is that is a saturated hydrocarbon. So in this case, as you could see that this two carbon atoms are having a double bond in it. So there is also, we could see that two hydrogen atoms are there in the hydrogen molecule. So among that, one hydrogen molecule will go over the carbon so as to satisfy the valency, and another hydrogen will also go over here so as to satisfy the valency, making the whole molecule to turn into this. That is nothing but an alkane. So this is how we can prepare alkene. This is how we can prepare alkane from alkene. So the one more condition that is been required, because reactions are those where we could convert a form of a chemical to different form of a chemical, and we could say as a reactant to a product, but there are different conditions also that was been required. So in this case, the main condition that was been required was introduction of catalyst. So in this case, the rare nickel is been acting as a catalyst so as to convert the alkene into an alkane in presence of hydrogen. But moreover, this condition don't take place in a cold condition. We have to provide heat, or we have to warm the solution. So that's the reason this symbol of heat is being introduced while representing the reaction. So this is how we could prepare an alkane from an alkene. So this is the general formula, or this is the general reaction that I have presented in front of you. But let me give you an example. So the example are as follows. Suppose if we have an alkene, that is the first alkene that we know, that is known as ethene. Suppose this is ethene, for which we have taken a reaction and we have to convert this into an alkane. So in this case, the thing that we have to do is we have to do hydrogenation. And what is hydrogenation? Hydrogenation is the process of conversion of an unsaturated hydrocarbon to a saturated hydrocarbon in presence of, that will be in presence of hydrogen itself. So that is introduction of hydrogen molecule to a unsaturated hydrocarbon so as to convert into an alkane, that is known as hydrogenation. So this is the process where we will do hydrogenation. So hydrogenation is nothing but introduction of hydrogen molecule. So suppose if I have represented the hydrogen molecule in the form of this one, in this case, that is both the ethene and the hydrogen, the both are of gaseous phase. And what we could see, suppose if we have to convert this into an alkane, so this reaction can't take place by its own. We have to introduce an catalyst, or in the sense we could also say that this reaction will happen, but it would require more time so as to get a product. So therefore what we are doing is we are introducing the catalyst. So that catalyst is nothing but Rane nickel, that is a highly porous nickel metal, or we could say highly crushed nickel, so as to form a small product, because the more the surface area, then only this process will take more fastly, or we could say that because the catalyst is also dependent on the reaction is also dependent on the surface area of the catalyst. So if the surface area of catalyst is more, then the reaction will takes place more rapidly, or we could say that the rate of reaction will be more. So Rane nickel is nothing but the highly porous, or we could say that highly crushed nickel particles. And now what we could say that the reaction will take place, because the condition is also been suitable, because heat is also been represented in the overall reaction. So the reaction will take place in this manner, where one of the hydrogen will acquire or will try to attack on the carbon atom, and another one would attack on this one. So now this is a simple thing that we have. Whenever we will write the reaction, there should be a significance that how the reaction had happened. So in this case, basically the CH2 double bond CH2 will, in which basically the hydrogen will attack on one of the CH2 molecule, and another hydrogen will act on another CH2 molecule. So now if this process happens in this way, so that the process after the completion of process, the thing that we'll get is, earlier it was CH2, but because of the hydrogen, what we'll get CH3, and the double bond will be broken, and what we will get is single bond, and in this case we have got CH3. So CH3 single bond CH3 is nothing known as ethane, and ethane is nothing but an alkane. So this is how we can prepare an alkane from its corresponding alkene by using hydrogenation process. And moreover, we could see that the number of carbon atom in this case earlier was 2 when we have taken reactant, and now after the reaction has been completed, then also we could say that the number of carbon atoms are same. So this is why I'm just only specifying about carbon atoms, because there are also some reactions in which we could see that after the reaction the number of carbon atoms has been reduced. So this is a reaction where the carbon atom remains the same. And so this was one of the reaction, or one of the example of the process where we have converted, or what we have did, a hydrogenation of alkene, and we have made this one. So let me give you another example, so as it would be very much easy for us to understand that hydrogenation is not so much complicated, or moreover it is very easy to convert an alkene to an alkane. So for that, let me give you another example. Suppose if we have this molecule, that is what would be the name of this molecule? It would be very much easy to, because of understanding of IUPAC nomenclature of alkene. So in this case we will get to know that this is the one that will have the name, because the name will also says the position of the substituents, and in this case, as we could see, that this would be the number 1 carbon, second and third. So as we could see on the second carbon atom, and this is the longest chain that we have, and on the second carbon atom the methyl group is being presented. So therefore we could write it as 2-methyl, that is this one, that is 2-methyl. And this overall molecule having a straight chain or continuous long chain of carbon atom consists of 3 carbon atoms, and 3 carbon atoms means nothing but propane. But this is not an alkane, this is an alkene. So therefore the name of this would be prop. But the position of carbon, the position of unsaturation, or we could say the position of double bond, it starts from the carbon number 1. So therefore the name of this would be prop 1ene. So this is suppose an alkene that we have, and we have to convert, or we have to do a hydrogenation process on this thing. So the thing that we have to do is we have to introduce the hydrogen molecule itself. So in this case what we are going to do, we are introducing the hydrogen molecules, and this represents the bond between the hydrogen and hydrogen. And now the reaction won't take place by its own, so therefore we have to provide a catalyst in the reaction. So therefore what we are taking is, we are taking a Rane nickel, and in presence of heat we will do the reaction. And what will happen, it would be easy to understand, as you have did earlier also, and we have did in general reactions also. So in this case basically one of the hydrogen atom will combine with this CH2, while other one also combine with the other unsaturated carbon atom, or basically this carbon atom. So now we could say that the result that we'll get, or the product that we'll get, is basically CH3. Now in this case the H has been introduced here, so CH. Now this CH2 has been converted into because of introduction of hydrogen in it, so now this has become CH3, and now this methyl was as it is. So this is an alkane because we can't see any kind of double bond between carbon and carbon atom, and moreover we could see that the carbon and carbon atom have a single bond between them. So that's why it's an alkane. But what is the name of this alkane? We have did the IUPAC earlier also, so it is very much easy to understand that the name of this would be, because we'll name it first, that is 1, 2, 3, and in this case basically the second carbon atom consists of methyl group. So therefore the name of this molecule would be, yes, it would be 2-methyl propane. It is nothing but an alkane. So this is how we have converted an unsaturated hydrocarbon, basically and specifically an alkene to alkane. So for that we have introduced analytical, and yes, we have did hydrogenation. But one more unsaturated hydrocarbon is remaining, and that type are basically known as alkynes. So let us try about that also, that how can we convert alkynes to alkane. Let us do that. Talking about alkynes, alkynes are the one which has a hydrocarbon which has at least one carbon-carbon triple bond. So suppose if we write the general reaction of that, so then general reaction are the main thing that we should make concern, because suppose if at anyhow, suppose if you don't know the reaction, but if you know the general reaction, you could utilize that reaction and you could solve that particular reaction or that particular incomplete reaction if it has been provided to you in exam. How? Let me give a general reaction of an alkane, and from which we could make alkane. That is, suppose if I have provided you an alkyne, and from that we could make alkane. How? Let us look at that. Suppose if we have, I'm writing the general reaction. So this is a general representation of alkyne, and not the general formula that we know, because general formula or general molecular formula. So in this case basically we could say that these two are, or these two are the alkyl group that can be same also, as well as that can be different, and moreover they can also be hydrogen. The both can be hydrogen, or among that only one can be hydrogen. So we'll go with the example also. So therefore this is the general representation of an alkyne, which consists of, at least you could see that there is at least one carbon-carbon triple bond. So therefore this is an alkyne. I would write over here, and for this I have to convert into an alkane. But this process don't take place directly, and because the thing is, this will be converted into first alkene, and then alkene will be converted into alkane. But this is a rapid process where we could see that alkene is being directly converted into alkane. But there are a few steps that are been involved in this. Let us discuss about that too. So in the previous lecture that we have, or in the previous reaction that we have saw that the carbon-carbon double bond with the introduction of hydrogen has become carbon-carbon single bond. So in this case also similarly, suppose if it is carbon-carbon triple bond, and because of the introduction of hydrogen gas, so now this carbon-carbon double bond, triple bond will be break, and it will be formed as a carbon-carbon double bond. So now therefore the reaction will be the same as we have did earlier also, that is we are doing the hydrogenation process, and this is the first hydrogenation process where we have converting an alkyne into alkene. How? Let us see. Where one of the hydrogen will attack on the carbon atom, or it will try to substitute or break the bond so as to make the valence of the carbon atom, and again one this bond would be break. Among this the pi bond would be broken, and this the middle carbon-carbon single bond is nothing but the sigma bond. Now this carbon-carbon single bond among the three carbon-carbon triple bond, that is one of the bond would be carbon-carbon sigma bond, while the other are carbon-carbon pi bond. So these pi bonds are very easily to break because they don't have so much of that is head-on collision, because pi bonds are made because of the lateral collision of the p orbitals. So because of which it is very much easy to break them, and that's the reason the hydrogenation process can take place. And because of which among these two carbon atom as we could see that there is presence of triple bond. So the one of the weakest bond, that is one of the pi bond, will be broken, and this would be converted into basically a carbon-carbon double bond. So now the answer that we could get is, or the overall reaction that we could get is in this case, but this reaction will take place in presence of nickel. So therefore we will write nickel over here, and in presence of heat or in a warm condition. So now this has been converted into, I would write over here where this is now been converted into R C double bond C R dash, and one of the hydrogen is been attached over here, and another hydrogen is attached over here. So now this has been converted from an alkyne to alkene. But the reaction is not yet over, because this process will go on continuous. The reaction will go on continuously, and it will be converted from triple bond to a single bond. And moreover, we could say that the hydrogenation process in presence of nickel is not a controllable process, because this will convert any kind of carbon-carbon double bond or triple bond to directly carbon-carbon single bond. So therefore, this won't be stable up till here. The reaction will be more yet. Yes, the reaction, that is the hydrogenation process, will be more, and we could see that again the hydrogen gas has been introduced. It will be introduced, and we could see that this hydrogen will attach over here, and another hydrogen will attach over here, making the molecule to be called as, or to be written as, to be represented as RCH2 single bond, because double bond will break, because in carbon-carbon double bond also, or we could say about alkene, then one of the carbon-carbon, that is single bond, that they have, because we know that it has a double bond, and one of the bond will have carbon-carbon sigma bond, while the other one will have carbon-carbon pi bond. So one of the weakest bond, that is the pi bond, will break, and this will be giving us RCH2 R dash. So this R, both the R that are been present over here, that is R and R dash, they both can be hydrogen also, as we have discussed. So now as you could see that this carbon atom have carbon-carbon single bond. That's the reason now they are called to be alkane. So we could also make the overall reaction or overall general reaction to be represented in such a way that we don't have to write the reaction twice, because practically this reaction takes place in such a manner where alkyne, when it undergoes hydrogenation in presence of nickel, it directly converts it from the carbon-carbon triple bond to carbon-carbon single bond, that is alkane. So that's the reason we could, for representation of this, we could also write it as alkene, that has been given over here, plus 2 times of, or the stoichiometry of the hydrogen would be 2 times of H2 gas, and in presence of nickel, and it would have given us directly, that is RCH2 CH2R. And moreover, if you observe that if I have taken the number of reactant as 2, the number of product is found to be 1. So this implies that this kind of reactions are known as addition reactions. And again here also, if I have taken the number of reactant as 2, then in this case I have got only one product, I don't have got a byproduct. So making this reaction to be called as an addition reaction. So this is the representation of conversion of an unsaturated hydrocarbon, basically and specifically alkyne to alkane. But let me represent it by giving an example. Suppose we have this as an alkyne, and this alkyne, as you know, that it consists of carbon-carbon double bond, and this is the alkyne, and as you could see that there is carbon-carbon triple bond and only 2 carbon atoms, making this hydrocarbon to be called as ethyne. So in this case, suppose if I did hydrogenation, that is if I have introduced hydrogen, which is a gaseous material, and in presence of that is nickel, and I have heated it. So this ethyne will be directly converted into alkane, and that can't be controllable unless we use another catalyst that could be controlled over this thing. So this is the thing where we could see that the stoichiometry of the hydrogen will be double, or we could say that 2 times of hydrogen will be used in the overall reaction, and now this product would be converted into, that is, HCH2 single bond CH2H, or this could also be written as very we could also simplify this, and so as to we could write as CH3 single bond CH3. Basically this is an alkane, and specifically we could say that this is nothing but, yes, it is nothing but ethane. So this is how we could convert a ethane or an alkyne to basically an alkane, and the number of carbon atom would not change and it would be the same thing. So let me give you another example. Suppose if we have this molecule, suppose this is the molecule that we have, and we have to do the hydrogenation process, or we have to convert this unsaturated hydrocarbon into a saturated hydrocarbon, basically alkane. So now the thing that we will do is we will introduce the hydrogen atoms or the hydrogen molecules. That is, we will use twice hydrogen molecule that would be in gaseous state, and in presence of a catalyst, that is nickel, and we will do it in a hot condition, or will warm this solution, warm this reactants. So the thing that we'll get is, we'll get the product to be CH3 C single bond C CH3, and in this case we could see that there are 4 hydrogen atoms, so therefore 4 hydrogen atoms will attack the unsaturated carbon bond, and now the product would be in this form. There are 4 hydrogen atoms in over this case, and this is the introduction of the 4 hydrocarbons in the carbon-carbon triple bond, making it as carbon-carbon single bond, and these are the hydrogen that we have. But what would be the name of the product? It would be very easy to understand that the product name would be methane, ethane, propane, butane, because 4 carbon atoms are there, so we could call it as basically butane. But what about the reactant? The reactant actually involves 4 carbon atoms, and moreover we could see that there is a carbon-carbon triple bond, and for naming that we know that it should we should select the longest chain, that is the IPC that we have learned about that, and we have to specify the double bond in such a manner, we have to give the number to the carbon-carbon double bond or triple bond in such a manner that it should get a least number. So therefore this is symmetrical molecule, and we could name it from anywhere. Suppose if I have named it from here, that's 1, 2, 3, 4. If I number it from here, so in this case what I could see is, I could see that the carbon-carbon triple bond starts from the second carbon atom, and overall the hydrocarbon consists of 4 carbon atoms, making this to be called as and moreover we could see that this molecule consists of basically 4 carbon atoms called to be but-2-wine. So the name of this would be but-2-wine or butane. So this is the thing that we have converted an unsaturated hydrocarbon to a saturated hydrocarbon, basically known as alkanes. So this is an example where we have discussed about how we have converted an unsaturated hydrocarbon to a saturated hydrocarbon, that is alkane. Now we have did earlier, that is how can we prepare the alkane from an unsaturated hydrocarbon, that is separately for from alkene as well as from alkyne. So now we are going to step towards the next one, that is how can we prepare alkane from sodium salt of carboxylic acid. Carboxylic acid is nothing but the group that it contains a carboxyl group, that is C double bond OOH, that is this one. So now we have to make, or we have to just consider the sodium salt of carboxylic acid. So if I made this group to be called as RC double bond OH, then this is nothing but a carboxylic group, a a compound which is nothing but a carboxylic acid, and it consists of a carboxylic group. But now, what if I have introduced the sodium in case of the hydrogen that it has? Suppose instead of hydrogen, if I have introduced sodium, so now this would be called as sodium salt of carboxylic acid. So now this is sodium salt of carboxylic acid, and from sodium salt of carboxylic acid we have to prepare an alkane. So how can we do that? That is, for this kind of reaction we will introduce calcium oxide and we will warm it. But this reaction won't take place by its own. We have to provide another reagent, and that reagent is nothing but NaOH, that is sodium hydroxide. So now, what is the reaction that happens? Suppose if I have introduced the sodium salt of carboxylic acid, this is sodium salt of carboxylic acid, I will write it over here. This is sodium salt of carboxylic acid, and this is sodium hydroxide, and in presence of that is calcium oxide, and we are warming the solution or warming the reactants. So what will happen in this case? The thing that will happen in this case is this NaO along with this COONA, this would be removed. So if this gets removed, then it could be written as Na2C. This is O1, O2, O3. So we could write it as, so Na2CO3, that is sodium carbonate, will be the byproduct, and as we know that after heating this process, basically the sodium carbonate will be separated, and if the sodium carbonate gets separated, and what the else that has been remaining, the thing that has been remaining is nothing but the alkyl group and hydrogen. So alkyl group is the one which consists of one hydrogen less, and if that alkyl group has an introduction of an hydrogen over it, then we could say that the alkyl group has now been converted into alkane. So now in this case, basically R and H, if they both combine, or an alkyl and hydrogen, if they both combine, they will form an alkane. So this is the process where we can convert a sodium salt of carboxylic acid to its alkane. But one thing is noticeable, and what is that? As you could see that this happened with a loss of carbon atom. So as you could see that it contained a carbon atom earlier when we have talked about sodium salt of carboxylic acid, and after doing this process, that is after introduction of sodium hydroxide and in presence of that is calcium oxide, and by warming it, we could see that one carbon atom is less in this alkane. So this implies that the carbon has been removed in the form of that is carbon dioxide, or in this case basically this whole thing has been removed, that is C double bond O and O. This has been removed. So this kind of process where the carbon dioxide also gets removed is known as a decarboxylation. So therefore this is a process which is also called to be as a decarboxylation process. So therefore what is the ultimate thing that we are going to talk about? That by decarboxylation of sodium salt of carboxylic acid, we can convert the sodium salt of carboxylic acid to its alkane with one carbon atom less. So this is the general reaction of the reaction. So this is the general reaction where we could convert sodium salt of carboxylic acid to a alkane. So this is what we could write over here as a general reaction. But let us understand that what are the different examples from which we could learn more things about the conversion, this conversion or this method of preparation of an alkane. So let us talk about them. Suppose if we have a sodium salt of carboxylic acid like this one, if I am representing it, that is CH3 C double bond O ONA. If instead of Na or instead of sodium, if H would have been there, then this could be called as acetic acid. or basically we know it as ethanoic acid when it comes to the IUPAC naming. So now it is called to be basically sodium salt of acetate or sodium salt of acetic acid, or the common name of this would be sodium acetate. So sodium, this is the sodium acetate, and moreover we could see that this is nothing but the sodium salt of carboxylic acid. And so for that, from this we have to make, or we have to prepare actually an alkane. So we will do a decarboxylation process, but the decarboxylation process don't take place by its own. We have to introduce some reagents, or either we will heat it. But as we could see that this is a sodium, and that's the reason it can't be removed directly by heating it. So therefore we have to remove, or we have to introduce the reagent so as to remove this as a byproduct. So what is the thing that we'll do? That is, we will introduce basically sodium hydroxide, that is NaOH, in presence of, that is, calcium oxide, and we will heat it. So this process, what will actually happen? So this NaO, that is sodium oxide, as you could see here, so this will be now able to remove this as a reagent, and the thing that is being left with us is basically a methyl group, that is CH3 and H. So CH3 and H, that makes basically CH4. So therefore both the reactants that has been left, that is the CH3 and H, they both will come towards each other, and we will get basically CH4. Simple. But what is the byproduct? The byproduct, as we could see, that it consists of Na2CO3. So this is the byproduct that we have got. And what is the main product that we have got? That is the byproduct is sodium carbonate, and the main product that we have got in this case is methane, and methane is the one which is present in a gaseous state. So therefore this is the one where we have converted sodium salt of acetate to a methane by the process known as decarboxylation. And here, as you could see, that the total number of carbon in this case was 2, but now it has been 1. So that is the reason it is named as decarboxylation. So this was an example where we have converted sodium acetate to a methane, or to a alkane. So we have another example also. So let us try about that, and let us see what is the thing that we could get. Suppose we have sodium salt of carboxylic acid, and that carboxylic acid is this one. So as we could see that the total number of carbon atom in this case is 3, and 3 carbon atoms in terms of a hydrocarbon, basically saturated hydrocarbon, is known as propane. But now this is a sodium salt of carboxylic acid, so therefore the name of this could be given as sodium, and this is nothing but 3 carbon atoms are being present, that is propane, in terms of a saturated hydrocarbon. But the name of this would be converted in will be now, because of this oxygen atoms, will now be propionate, that is sodium propionate. So now, because it is sodium propionate that we have, and we have to do the decarboxylation process so as to make an alkane. So the thing is, we will introduce, again it is very much simple to understand, that is we will introduce NaOH, that is in presence of calcium oxide, and we'll heat it. So the thing that will be removed is basically this whole group that has been attached to the alkyl group. Now this whole group will be removed along with sodium oxide. So now the thing that has been left, or that has been removed as a byproduct, is nothing but Na2CO3 is the byproduct that has been removed. But what would be the main main product? So the main product, as we could see, that this is an alkyl group that we have, and this will be now combined with the hydrogen so as to make an alkyl, which will now be converted into an alkane. And moreover, we could see that it consists of 2 carbon atoms, making this to be called as ethyl. So now ethyl, when combines with hydrogen, it forms ethane. So we could write this as C2H6, that is known as ethane. So this is what we have. So we have converted basically sodium propionate to ethane, and we could also see that one carbon atom is been less, and this process is basically known as decarboxylation. And this is the one where we could prepare a alkane from sodium salt of carboxylic acid. So now we have discussed about how can we prepare a alkane from its sodium salt of carboxylic acid. Suppose if we have this question that has been present on your screen, and it says that how can we prepare propane from a sodium salt of carboxylic acid. So now this is a bit challenging, and we have to think a lot about it, that how can we make propane from the sodium salt of carboxylic acid. The reason behind that is they have not mentioned that what sodium carboxylic acid it is, or might be it is sodium acetate, or might it be sodium propanoate, what we have. So we have to think about that, and what would be the conclusion, because we know that it has been provided with sodium salt of carboxylic acid, and we know that sodium salt of carboxylic acid is the one that will undergo decarboxylation. That is, after the decarboxylation we will get a product as Na2CO3, and a main product has to be alkane, and that alkane will have one carbon atom less than compared to that of its original sodium salt of carboxylic acid. So this implies that if we have to prepare propane, as you could see here, so if we have to prepare propane, and the propane is the one which consists of basically 3 carbon atoms, so its sodium salt of carboxylic acid will contain 4 carbon atoms. So therefore what we have to do is we have to represent the 4 carbon atoms in the form of the sodium salt of carboxylic acid, and then we have to do the decarboxylation process so as to get propane as a product. So let us do that. How can we do it? See, the total number of carbon in propane is 3. So now, because of we are writing at sodium salt of its carboxylic acid, where it will contain more number of carbon atom, that is where it will contain more number of carbon atom. So now we could write it as CH3, CH2, again CH2. This has made a total number of 3 carbon atoms, but we have to represent it in the form of carboxylic acid, and moreover sodium salt of carboxylic acid. So what we are going to do, we will introduce a carboxylate group, that is C double bond O, O, Na. Now what we will do is we will do the decarboxylation process by introduction of, that is, NaOH. And now what we are going to do, we'll represent, or we'll do the reaction in presence of, that is, calcium oxide, and in presence of heat. And in this case what we are going to see is, we'll see that this group, that is C double bond ONA, this group along with ONA will be removed as Na2CO3, basically known as sodium carbonate. So now the thing that has been left with us is basically a propyl group, that is CH3, CH2, CH2 group, that is a propyl group, and propyl group is the one which is basically a propane with one hydrogen atom less. So this is the one propyl that we have, and this will combine with the hydrogen that has been left out of the sodium hydroxide. So now what will happen is this will combine with the hydrogen so as to form CH3, CH2, CH2 plus H, that has become CH3, basically known as propane. So this is the product that we have got. So this was a question where it had got us, or it has made us to challenge that from which kind of sodium salt of carboxylic acid would be it would be prepared from, because there are multiple sodium salt of carboxylic acid. So this is what we have chosen, and we have chosen that the carboxylic acid is the one which consists of the sodium salt of carboxylic acid will be the one which consists of 4 carbon atoms, and after decarbonization it will convert into a carbon atom or a hydrocarbon atom which consists of 3 carbon atoms. And now what would be the name of the reactant that we have used in this case, because in this case the sodium is this will form a salt of carboxylic acid. So therefore the name of this reactant is sodium butyrate. So sodium butyrate is the name of this carboxylic acid, and after the decarboxylation process we'll get propane. So this is how we have made a alkane from the given question that was being provided to us. Very easy to understand. So now, after doing the preparation or the method of preparation from a unsaturated hydrocarbon, and that is sodium salt of carboxylic acid, now we are going to prepare a alkane from an alkyl halide. So this is how we are going to prepare an alkane from alkyl halide. But there are two methods from which, or the two other preparations from which we could prepare an alkane from an alkyl halide. That is, the first one is using zinc copper couple, that is an alcohol. So this is the first method from which we could convert an alkyl halide to an alkane, while the other one is using sodium metal. So these are the two methods where from which we could convert an alkyl halide to an alkane. So talking about the first one, that is using zinc and copper couple. So this involves basically the reduction of the alkyl halide, where we are using not the hydrogen molecule as a gaseous phase, but we are using the nascent phase of the hydrogen atoms. So what are those? Let us talk about in this thing. That is, we are going to prepare an alkane from sodium copper coupling or sodium copper couple, and for that we need hydrogen, because hydrogen is the one which will reduce the alkyl halide and we will form this reaction that we have. That is, this Rx represents where R is the alkyl group, where X is known as halide. So therefore, making it to be called as alkyl halide. So this alkyl halide will be reacted with basically in presence of zinc, copper and alcohol, and we have to heat it. So whenever zinc copper, this couple is been reacted with alcohol, it will produce hydrogen, and those hydrogen that it will be produced, that will be because of that the zinc and copper has been reacted with alcohol so as to produce nascent hydrogen atoms. So therefore, in this case, what will happen is we will get two nascent hydrogen atoms, in which among the two nascent hydrogen atoms, one hydrogen atom will be removed, or one hydrogen atom will be involved with this X so as to form HX, while the remaining hydrogen atom will be with the alkyl group, and yes, we will get basically an alkane. So this is how we can convert a alkyl halide to its alkane by using this reduction method also. And this reduction method doesn't involve as earlier that we have did, that is we have converted an unsaturated carbon atom to a saturated hydrocarbon, basically alkane. And in this case, this is also known as the reduction process, where we have involved the hydrogen molecules to react with the alkyl halide, and so as to remove the halide atom and to replace it with the hydrogen atom. So now this hydrogen atom that we have got is because of the zinc copper couple that has been reacted with alcohol. And as we know that when sodium is also, when it has been reacted with alcohol, it produces hydrogen. So hydrogen as a gaseous phase. So now in this case, basically zinc couple reacts with the alcohol to form nascent hydrogen atoms, and basically highly reactive hydrogen atoms that would react with alkyl halide so as to form alkane. So let me give you an example for this, that how can we prepare a particular alkane by using a specific alkyl halide. Suppose if we have CH3Br, named it as methyl bromide, or we could also say it as bromomethane. In terms of IUPAC, that is bromomethane is the one it has been called. So suppose if we have reacted this with nascent hydrogen, and how the nascent hydrogen will be produced, this is the one that we have got to know here itself, that is it will be because of zinc copper plus alcohol if we react it with that one, and if you heat it. So in this case, what happens is, because the one of the H will take away the Br from here, so therefore the byproduct will be basically HBr, and the remaining thing that has been left with us is basically this CH3 that is with us, and means that is not been evolved along with the Br, but it is still with the as a reactant, and it will take among the two only one hydrogen it will take from there, and so as to produce basically CH3H, or we could write it as CH4, making it to be called as methane. So this is how we can prepare a alkyl halide to an alkane. So the naming of this was very much easy, and how the question will be asked. The question will be asked in a very simple format, that is, how can you prepare, that is, methane from alkyl halide. So this is the one that we can do, and we have two options, because earlier also we have discussed that we could prepare that is methane from using zinc couple, or we can prepare an alkane from zinc couple and using sodium metal. But this reaction is only possible when zinc couple is being used. In this case, sodium couple, if you introduce sodium, then that is the Wurtz reaction that we are going to talk about. Then in this case, basically the methane won't be produced. But in this case of, that is, zinc couple, if we are using, and we can prepare methane from that, but that cannot be prepared from using sodium metal. So both the processes are different, and they have quite a limitation, but this reaction don't have limitation, and we could prepare a particular alkyl halide to its alkane. Suppose if another example that we have, and in this case we are being asked for basically the conversion of a alkyl halide to an alkane, and suppose the alkyl halide is being suppose the alkyl halide is this, that is, it has been called to be basically 2-iodopropane. Suppose if 2-iodopropane is with, suppose if 2-iodopropane is with us, and we have to convert it to a particular alkane. So what is the thing that we have to do is, we have to, that is, react it with the zinc couple and alcohol. That is, we have to make it to undergo through a reduction process, where we could get two nascent hydrogen atoms, or nascent hydrogen species, and this now will be because of the zinc copper couple and alcohol, and we'll heat it. So in this case, what is the thing that we'll get is, because one of the H will take away this I, or will remove this iodine, so as to form Hi to be called as the byproduct. But the thing that has been remaining with us is basically CH3, CH3, and among this two nascent hydrogen, one has been gone with the iodine, and the one is been remaining, that is, that hydrogen will be involved here, so as to make it as, and name of this is nothing but propane. So this is the reaction that we have made, that is from conversion of an alkyl halide to a propane. But in exams, how the question would be asked? Suppose the question would be asked in this manner, that is, how can you convert 1-iodopropane to propane? So this is the question that they could ask. So you could apply any of the method, but if they are specifying that the iodopropane is been now converted into propane, then in this case, because the number of carbon atoms is not being changed, so it will remain the same as it is. And I have specified earlier also, because there will be some kind of reaction where we have to observe that the number of carbon atoms are same or not. So this is the only case where the number of carbon atom remains the same, and that kind of alkyl halide is being converted into a alkane, that is propane in this case. So this is how, where we will only use, that is, zinc couple and alcohol, so as to prepare a particular alkane. But the another question can also be asked in this manner, that how can you prepare propane from that is from an alkyl halide using zinc copper couple alcohol? So this is the question that they could ask, or they could give you an incomplete question and we have to fulfill that. For example, this is one. Suppose if they have mentioned us a question which is basically incomplete, that is, So suppose this is the reaction that has been provided to us, and we have to find that what would be the reactant. It is very easy to find out that what would be the reactant, because as you could see that the total number of carbon atoms that has been produced as a product in this case is 2, making it to be called as ethane. And moreover, these are the reactant species that are been given to us, and the conditions are also been given to us, where it has been zinc and copper couple are been involved with alcohol, and the 2 hydrogen has been produced. But what would be the alkyl halide? That is the main important thing. So as we could see that this is the one which consists of 2 carbon atoms. That means the reactant will consist of 2 carbon atoms, and it would be an alkyl halide, and the halide would be, because of HCl we could see that the halide is nothing but the Cl atom. That is the chlorine atom. So therefore we could write it as in this format. That is, the given reactant would be CH3 CH2 Cl. So this is the reactant that we have, and we could name it as chloromethane, also chloroethane. And because of which, that is, one hydrogen will take this HCl to form HCl, and one hydrogen will involve over here so as to form basically ethane. So this is the reaction where we have converted a chloroethane to basically ethane. So this is also, they can give you, or else they could give you the reactants and they will ask you for the product. So the question, for suppose if the question has been asked in this format, so what they could ask you? So they could ask you in 2 manners. That is, the first question is, how can you convert chloroethane to ethane? This would be the first question. So in this case we have got to know that the chloroethane is nothing but an alkyl halide, and alkyl halide has to be converted to an alkane. So therefore we have to use basically zinc couple and zinc copper as the couples of the metals, and we have to use alcohol. So from that we will do the hydrogenation process and will make ethane. So, or else they could ask you in this manner that how can you prepare ethane from chloroethane. So these are the 2 things that they could ask. So it would be very simple to understand, but yes, whenever they will ask you that you have to prepare something, so that product or that name that they will give you, like prepare something, like prepare ethane, so that ethane will be on the right hand side of the arrow, while the word, if they haven't given to you or in the form of question, that is, you have to prepare from, and that from will be nothing but the reactant. So these are the 2 things that we should be very careful of, because most of the mistakes are being done by misunderstanding the question. So that is happens, human error. So now let us talk about the another one that we have discussed about, because we have discussed about the alkane can be prepared from an alkyl halide, and from that we have got to know that alkane can be prepared from using zinc copper couple as well as alcohol. But now we are going to talk about that how an alkane can be prepared by using sodium metal, and in that case basically alkyl halide is also been involved. So let us talk about that. So now let us discuss about that how the alkyl halide will be reacted with the sodium, and from that we have to prepare basically an alkene. So let us talk about that. Suppose if Rx represents the alkyl halide, and on which we have to react it with sodium metal. So the reaction of the sodium metal and the alkyl halide takes place in presence of basically dry ether and heat. Yes, so this is the reaction that takes place, and where we have to convert an alkyl halide into an alkane. But this reaction doesn't take place by only reacting with the sodium with only 1 mole of that is alkyl halide, because the sodium will take away this X so as to form the sodium halide. But what will be with the alkyl group that is it? So now sodium will react with only 1 mole of alkyl halide. So what will happen if the NaX will be produced and only the alkyl group will be left? So this is not happen. So for that what we are going to do is we will introduce basically 2 times or 2 moles of alkyl halide and 2 moles of sodium. So in this case what happens is, because the reaction takes place in presence of dry ether, then the only possibility thing is that is been remained with us is, that is, the sodium will now take away this X or this halide, while the other, it will also involve the removal of sodium and the halogen atom. So for that, what we will get is we will get 2 moles of NaX plus the reactant that is built, the reactant now that is with us is basically an alkyl group and an alkyl group. So now they both will couple with each other so as to form an alkane. So this is a process where we have converted an alkyl group, that is an alkyl halide, that is Rx, to an alkane, in which we see that the number of carbon atoms now are been doubled, because these are the 2 moles of the alkyl halide that was been involved, and in that case also, so as to complete the reaction, we have introduced the sodium metal. And sodium metal, when all these reactants were been involved in presence of dry ether and we have heated and made a reaction, we have got R-R, or basically we call it as an alkane. Even this is an alkane, it consists of basically 2 alkyl groups, and 2 moles of NX has been removed as a byproduct. So this kind of reaction is basically known as Wurtz reaction. So this is a reaction where the alkyl groups gets coupled and form more number of carbon atoms so as to get a hydrocarbon in which the sodium is also been involved. So basically this is a reaction which is in which alkyl halide is been involved so as to form an alkane, but the alkyl halide will form an alkane with respect to that the carbon atoms are now being doubled, or we could say that the carbon atoms are now being increased. So this is how we can prepare an alkane from Wurtz reaction. So this is a very important reaction that we are going to discuss about. So let me explain this general reaction of the Wurtz reaction in presence of some other examples. So let us talk about that also. Talking about the first example that we can from which we could make an alkane, that is, suppose if we have methyl bromide, and methyl bromide is the one that we have to react it with basically sodium. So suppose if I have introduced sodium, and that also in presence of that is dry ether, and we'll heat it. So the thing that will be involved in this case, because the sodium has a valency of 1 and so has Br. So now therefore, so as to fulfill the valency of the carbon atom that would be remained as an alkyl group if this both two are being reacted with each other. So that's the reason we have to introduce another mole of that is alkyl halide, and similarly we can also introduce another mole of sodium atom. So in this case what will happen is basically the sodium will be now involved with the bromine and bromine atom, and again this sodium will be involved with the bromine atom so as to form basically 2 moles of NaBr, that is sodium bromide, and the rest that will be remain with us is basically this CH3 and this CH3. The both are the alkyl groups, that is methyl group and methyl group, but now they will couple with each other so as now they will now form that is CH3 basically known as ethane. So in this reaction basically we have converted methyl bromide to ethane. So this is basically known as Wurtz reaction, and Wurtz reaction takes place in presence of sodium and dry ether. So this is the reaction that we have made, and we have also saw that the carbon atom which was being involved in terms of reactant, if we observe that only 1 carbon atom was being involved in the reactant, and but now after the reaction has been completed we could see that the product that is been formed, it consists of 2 carbon atoms, that is the double than that of the previous one or the reactant that we have mentioned in this reaction. So this is how it happens, and the coupling of alkyl group takes place, and this kind of reaction is basically known as Wurtz reaction. So suppose what if we have introduced, this was a primary one, and what if we have introduced a secondary alkyl halide? So let us talk about that also, but let me give it through an example. Suppose if we have this as an alkyl halide, and from which we have to react it with sodium, or basically we have to do a Wurtz reaction of it. So what is the thing that we have to do? We have to take it 2 moles of that is the halide that we have, that is basically known as 2-chloropropane. So this is an alkyl halide that we have, and we have to react it with 2 moles of sodium, and that also in presence of, that is, dry ether, and we will heat it. So what is the reaction that we will get, or what is the product that we will get after the reaction? It is very simple to understand, because since we are involved in this case, because we are involved with 2 moles of alkyl halide. So therefore in this case, suppose we could write it in this manner, that is CH3 CH3 Cl, in which again 2 moles of sodium are also been involved. So therefore this is the sodium that has been involved in this case, 2 moles of sodium. So now therefore this Na will take away this Cl, while this sodium will take away this Cl, so forming 2 moles of NaI as a byproduct. And the thing that has been remaining with us is basically this as a couple. So therefore we could write it as CH3 CH3, a bond between this carbon and this carbon, and now this would be CH3, and this case it would be CH3. So this is the reaction that takes place. So what would be the name of the product? So for that we have did a IUPAC name also, nomenclature also, and in that case what we have got to know that we have to select the longest chain and continuous longest chain of carbon atoms. So now therefore the continuous chain of longest carbon atom can be decided to be this one, and now numbering can be started, because this is the IUPAC name that we have did earlier. So therefore it is very much beneficial for us to understand the IUPAC nomenclature that we have did in our earlier lectures, and now we are applying those thing here so as to determine that what will be the name of this product. So now I will name this carbon as to be 1, second, this would be the third, and this would be the fourth. So I could see that on second position and on third position I could see the methyl groups. So therefore the name of this kind of the product that we have got can be written as 2,3, dimethyl, and the total number of carbon in a straight chain or in a continuous chain is basically 4. So making to be called as having a parent carbon atom called to be as butane. So this is the answer that we have, or this is the reaction that we have made by introducing, that is 2-chloro propane. By introducing 2-chloropropane with sodium and dry ether we have prepared, that is 2,3 dimethyl butane. So the question can be asked in this manner also, as I have discussed about this earlier also. So therefore the question can be asked that how can you convert 2-chloropropane to 2,3 dimethyl butane? So this is the question that they could ask. But how can you determine that whether this reaction will undergo Wurtz reaction, or whether this reaction have to go with the zinc copper couple and alcohol, so that kind of reduction? So what would be the main reason behind to involve which of the reactions so as to form product? Because the both of the reaction are forming basically an alkane from an alkyl halide. So in that case only, the main important thing is the first reaction that we have did, that is when we have reacted an alkyl halide with the zinc copper couple. So in that case basically the number of alkyl halide, which was, suppose if it is 3, then the product will have a hydrocarbon which consists of 3 carbon atoms. While in case of Wurtz reaction, suppose if we have introduced basically 3 hydrocarbon atoms or 3 carbon atoms as an alkyl halide, and the product would be the double of that it would having 6 carbon atoms. This is how we could differentiate between the two reactions. So now suppose what if we have this as a reaction when we are talking about Wurtz reaction. So this is the Wurtz reaction that we have discussed, where we have involved a alkyl halide, and that is the thing that we have multiplied it with 2 so as to make the stoichiometry, and that is the thing that the number of carbon atoms involved in the product would be the double of the reactant. But what if I take this as the reactants, where I could involve basically CH3 Cl and C2H5 Cl. Suppose if this is the thing that I have involved, because this is the solution where I have involved methyl chloride as well as ethyl chloride, and I am introducing in this case sodium, and in that also in presence of basically dry ether, and I'm heating it. So the reason that what will happen is the reaction that it will happen, it will give us multiple products, and the reason behind that is basically, since as we know that as we know that the Wurtz reaction requires the sodium metal, and therefore it gives basically a coupling of an alkyl groups. So therefore this also can give a coupling of alkyl groups, but it is not necessary that it will give us, that is, ethane, or it will give us propane. So there would be multiple possibilities so as to give us the product. And what are the multiple possibilities? Let me talk about that also. Suppose if I am introducing 2 moles of sodium, and in this case suppose the reaction has been done in such a manner that one of the sodium has involved one of the Cl, while other of the sodium will take one Cl from it. So now the reactant that I will get is, the product that I will get is after the reaction can be CH3 C2H5. So this is the product that I could get, or might be if I have involved this, and this whole reactants are in a solution form, suppose. So it might also be the possibility that what we have taken in our earlier example of Wurtz reaction, that is the chloromethane when will react with another mole of chloromethane in presence of 2 moles of sodium. So now in this case, what is the product that we could get? We could get this one, that is CH3 CH3, that is called to be ethane. And suppose in that solution basically C2H5 is also been present. So now C2H5Cl, that is the ethyl chloride, will react with another ethyl chloride in presence of sodium so as to form basically butane. So this would be C2H5 and C2H5. So what are the products that are been involved, or what are the products that we will get in this reaction? Suppose if we have involved methyl chloride, ethyl chloride, and sodium in presence of dry ether. So therefore we will get 3 possibilities, or we'll get 3 products in that case. That is, the one would be propane, because as you could see that the carbon number here it is 2 and here it is 1. So making out the total number of carbon to be 3. So making this to be propane. This is the product that we'll get, that is ethane. And this is the one that we will get basically butane. So this is the one that involves the reactant. Suppose if the reactant is CH3, then this is what we have got, double that of the carbon atom. And here also suppose if the carbon atom is 2, and we'll get double the carbon atom of that, that is the total number of 4. But as you could see that this is where it has formed a mixed number of carbon atoms. That is, if this is 1 carbon atom, now this is 2, so making it to be 3. But this kind of reaction that it happens here, it is called as self-coupling, and this self-coupling makes to be formation of a propane. And that's the reason propane doesn't form by its own, because this is an odd number carbon atom. Because here also you could see that the carbon number atom is 2 carbon atoms are been involved, here 4 carbon atoms are been involved, but here 3 carbon atoms are been involved. So this kind of propane cannot be prepared from cannot be easily prepared from that is a Wurtz reaction. So that's the reason we have to use the method of the zinc copper couple and alcohol so as to convert an alkyl chloride, or we could say that is a propyl chloride, to convert into propane. So this is the thing that is the drawback of the Wurtz reaction. So they will involve, or we could make a propane from Wurtz reaction, but there will be different possibility, and yes, we have to take 2 different alkyl halides so as to make this product. But it is not necessary that we'll get only this product, we can get this product also. So that is the thing that it will happen. So that is the drawback of Wurtz reaction, that is we can make a hydrocarbon which consists of even number of carbon atoms, or even number of carbon atoms. That is what we can make from. So just as to make a quite glimpse of what we have did, that is from the conversion of an alkyl halide to an alkane, we have a question. So we have a question, that is, how can you convert ethyl chloride into ethane, and yes, how can you convert ethyl chloride to butane? So there are two different questions that they have been asked about, and from which the first one is to prepare ethane from an ethyl chloride. So what is the reaction that it would involve? So now let us do the first reaction that they have been asking about. So in this case, what we have to do is we have to convert the ethyl chloride into ethane. So in this case, how can we write that? So because they have asked us to convert ethyl chloride into ethane, so suppose we'll write the ethyl chloride on the left hand side, right? So therefore the ethyl chloride can be represented as C2H5Cl. So this is the ethyl chloride, and from which we have to prepare basically ethane. So the ethane is nothing but C2H6. So this is what we have to prepare. So among the two methods that we have learned, that is from alkyl halide, we have to prepare using zinc copper couple, and another one is sodium metal. So in this case, basically the thing that would be involved is very simple to detect, that the total number of carbon here is found to be 2, and here it is also found to be 2, that is in case of product. So because the carbon number has not been increased, or it has not been doubled, it is the same as it is. So therefore in this case, basically a logical thing that we are going to apply, that is in this case we are going to apply the reactants like that would be involved, that is zinc copper couple, and these are the reagents that would be involved in presence of basically alcohol, and we'll heat it. So after the zinc copper couple is been reacted with the alcohol, then the evolution of hydrogen, nascent hydrogen species will be involved. So therefore two moles of nascent hydrogen will be involved, in which one of the hydrogen atom will take away the Cl so as to form basically HCl, while the one H will be involved with the alkyl group, and in this case the alkyl group is nothing but that is ethyl group, because the name of this is ethyl chloride, that is one hydrogen has been less, and that hydrogen has been replaced by chlorine atom. So therefore this is called to be ethyl chloride. And from this ethyl chloride we have made basically ethane, or we have produced ethane. But the most important thing is we have included this as to be a reaction where we have introduced two nascent hydrogen in presence that had been because of the presence of zinc copper couple and alcohol, and in this case we have not applied the other reactant that we have did, that is Wurtz reaction. And talking about the another one, so this is the one that has been done, and let us talk about the another one. So the another one is been asking about that how can you convert ethyl chloride to N-butane. So let us do that also. Suppose if we have ethyl chloride that could be represented as C2H5Cl, and this is what we have to convert into basically N-butane. So N-butane can be represented as in this manner, that is CH3, CH2, CH2, CH3. As you could see, this is butane. But you will also observe that the total number of carbon on the reactant side, or in the ethyl chloride, is basically 2, while in case of N-butane that has been provided to us, that is this is N-butane, the product has been provided to us, and the thing that we have to do is we have to estimate that which of the reaction would be involved. So the total number of carbon atom here in ethyl chloride is 2 carbon atom, while in this case is 4 carbon atom. So the reactant has now which contains 2 carbon atoms is now been doubled, that is 4 carbon atom. That means 2 moles of ethyl chloride has been used, making 4 carbon atom on the product side, and this is only possible in Wurtz reaction, where we would involve 2 moles of sodium in presence of dry, where the byproduct that we would get is 2 moles of that is NaCl. So this is how we could prepare that is N-butane from ethyl halide, having or having double the carbon atoms like the compared to that of the reactant. So this were the two reactions where we have got an alkyl halide and we have used the same alkyl halide, that is ethyl chloride, but the products are been different. In the first we have got the product to be ethane, and in the second that we have got the product to be butane. So in this case also we have to also check that which of the method that we are using so as to prepare a particular alkane. So this all was nothing but the formation of an alkane that we have did. So these were the 3 methods that we have did, and talking about an extra thing that I want to mention, that is in this case basically ethyl chloride, or we could say we have converted an alkyl halide to an alkane. And talking about the reactivity, that which of the reactivity will have the most. So for that, suppose the alkyl halide can be represented in this way, that is this is for chlorine, this is for alkyl bromide, alkyl chloride, and this is alkyl iodide. Now talking about the reactivity of which one would be more? The reactivity of basically alkyl iodide will be more than that of the bromide, than that of the alkyl chloride. So this is the thing that I wanted to express, that the reason behind that the reactivity of alkyl iodide is more because of the atomic size of the iodine. If the atomic size of the iodine is more, and moreover we could see that because of which they will have a kind of whenever they will react with the other groups or other species, so in this case they would separate very easily, and because of which the reaction will happen. So that's the reason, because of the iodine which has a more atomic size compared to that of the chlorine, that makes the alkyl iodide to be more reactive than compared to the other one. So these were the methods of preparation of alkane that we have did, and this were all the preparation that we have did, and it was very easy to. So thank you friends for watching this video. I hope you have understood this video very clearly, and yes, you have got to know that how can we prepare alkane by using various methods that we have did in this lecture. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.